Granular materials refer to a group of macroscopic particles with different properties. Examples are plastic balls, grains of sand, or mixed nuts. When subjected to external forces such as shaking, the particles tend to segregate according to size and density. This size segregation is called the Brazil nut effect if the big particles rise to the top of the granular material, or reverse Brazil nut effect when big particles sink to the bottom. In the past decades, studies on BNE and RBNE are conducted on open containers. This study aims to examine the effect of an overhead structure on the segregation of a vertically vibrating binary mixture. Additionally, we want to observe the effect of different initial conditions on the exhibition of BNE and RBNE. The degree of segregation is computed using this equation, where lambda is the segregation index and h corresponds to the height of the center of masses of the particles. Using a discrete element method simulation software, we observed the behavior of particles undergoing BNE and RBNE. We found two things. Number one, the occurrence of BNE and RBNE does not depend on the initial mixing conditions of the granular mixture. And number two, a structure on top of a shaking granular material affects the segregation process of the mixture. The application of the sieve-like structure on top of the shaking granular material slows down the process of BNE segregation, and we can see that by comparing the evolution of the center of mass heights of the small and big particles. For RBNE, the sieve increases the difference of the center of mass heights between the big and small particles. We found that the application of the sieve-like overhead structure slows down the BNE segregation while promoting RBNE segregation for the case of a binary mixture. Studies like this pave the way for a better understanding of granular materials for applications in different industries such as mining, pharmaceuticals, and food packaging.